Hi, this is Mary Jo Webster. This video is going to give you an introduction to some basic data concepts that I think are necessary no matter what tool you plan to use for your data analysis. I'm going to show you a few things that I have in this spreadsheet. The spreadsheet is called Intro to Data. There'll be a link here with this video. And you'll see at the bottom that there's several sheets. This is in Google Sheets, by the way. All these concepts, though, apply to really any tool you want to use: Excel, R, Python, any other data analysis tool. So this is data that this is where most reporters start when they start thinking about data. They think about, I want that one number to put in my story. I want to be able to say how many more deaths there were from opioids last year than, say, 10 years ago. And that's kind of their end game, and they see that that's what they want to achieve. And so tables like this, where it's a summarized set of numbers, is usually what most journalists think of as data. And it's not in terms of those of us who do data analysis. This is actually really a bunch of information that has been given to us. And the reason, kind of the differentiation here, is that this doesn't allow us to ask very many questions. So we can ask that question that the reporter had: how many more deaths are there last year than, say, 10 years ago? By doing a simple math calculation, you could either do a raw number subtraction, the new number minus the old number, or percentage change over that time. And that would be a simple math calculation in this spreadsheet, or quite frankly, using a calculator if you really wanted to. So there's not much here. But what are all the questions you might have around opioid deaths that you might want to answer? And that usually might be things like, who were these people? Where in Minnesota did they live? How old were they? Were they male or female? What race or ethnicity? Is there any disparities in terms of race or ethnicity or genders or ages? What kind of drugs? How many involved fentanyl? Can we answer any of those questions with this data? No. We know that 493 people died in 2017, but we know nothing else about those 493 people, so this data is very limiting to us. I'm going to go to sheet 2 now. This is another iteration that you might see that gives us a little more detail. So this is taking those big totals and breaking it down by male and female each year. We also get a lot of data like this as reporters, and this does answer another question for us, allows us to look at that gender disparity or difference over time, and we can look at that over time and how that has changed, but it is still limiting in what we can do. When we teach data analysis skills, though, we do teach you how to do those math calculations, and that's usually where a spreadsheet class will start, is how to do a percentage change, how to add together things, how to subtract, divide, do a median or an average, and things like that. That's usually where we start, because you will have data like this that you will need. This might be all you can get, for example, from some states or local agencies, and so you need to answer those questions in a spreadsheet. So we will teach you that, but it is still limiting in what we can do. So let's go to sheet 3. Now this is getting a little bit better. This is the same data. These are people who died from opioids. And again, but now we have multiple rows for each year, and now we're seeing how many were female and African American, not Hispanic, how many were white and Hispanic, and all those different iterations, and then we're getting a total in that deaths column. So this is, if you can't get very detailed data, if your state only allows you to have summarized data to protect the privacy of the people here, then this might be your best hope. I frequently see agencies will instead give you this gender table like this, and then they would give you a separate table that would break down the race, and then a separate table that would break down the Hispanic ethnicity, but not a table like this where it puts them all together so you could find here's all the black males who, not Hispanic, black males who died from opioids each year. So this is a better scenario if you do have to go with summarized, but again, it's still limiting in what we can answer. We're getting a little better. So let's look at the gold mine. This is one row is a person who died, and we know a lot of things about that one person. So when you get a data set like this, you can start to look at even a one row. Let's look at the first person here. He was born in 1992, died in 2016, 23 years of age, white male. We could see he lived in St. Louis Park. He had a bachelor's degree, worked as in business management, IT risk advisor, never married. The death was ruled an accident. And then in here, there's some notes about mixing drugs, and it's listing some kinds of drugs. It's here. So this is, this is the thing we can, we could do that first table we looked at, how many people died each year, by using that death date column and pulling the year out of there, and we could say how many died each year. We can do that second table we got, how many were women, how many were men. And we could do that third table, how many by each gender, race, and Hispanic ethnicity. We can carry that up and make those same tables ourselves. Plus, we can make all kinds of other tables or do all kinds of other analysis, like where they lived, where they died. Could we possibly figure out how many died from fentanyl? Well, maybe, but when you start to dig in here, then you're looking at the cleanliness of the data. That's another level of things we need to think about. But we're a lot closer to being able to answer that question here than we were in those previous tables we were looking at. And the other thing to note is these other tables where it's all summarized up. We can't break this out in any way and say who are these 493 people. But we can take this gold mine, this detailed data, and collapse it up to that 493 or whatever grouping we want. And the other beauty of the very detailed data is you might, especially if you're able to get names, you could find anecdotes for your story. You can find those individual people that you want to write about, those particular situations that exemplify whatever it is you're writing about. And that's an important value of data that we don't always think about when we're talking about data analysis. So this is the thing you want to aim for. If a government agency gives you a table like this with the total deaths each year or anything that's tallied up, try to ask them, can I get the detailed records you use to create this table? And that's where you want to go. Okay, let's talk about a couple of other concepts. So here in sheet 5, this is also summarized data from the Minnesota Department of Health showing the most common causes of death each year over several decades here. And so this is not all causes of death, so we have to keep that in mind. These are just the top 20 or so. So we can't add up these columns to determine how many were there. Something to think about. But I wanted to use this to talk about the idea of tidy data and how you want your data structured. So you want no empty rows, no empty columns, one header row here. And you want to think of this data kind of like an island. You want to notice that I do have some notes at the top here, and that's totally fine. But then there's blank rows, at least one blank row, if not more, between your notes and your data. And then the same thing down below. You want to make sure that that row immediately below your quote island is blank. And the same thing all the way over to the right. And Sheets doesn't actually go out there. It's not going to show me blank space over there. So notice that it's all tidy, no empty rows, no empty columns. That's what you want. In sheet 6, I'm going to show you something an agency did to me when they sent me some data. When I first took a look at it, I was like, oh, this is very nice and very pretty. whatever. Well, they had put blank columns and made them really tiny, so they were just like these little gutters. And you cannot sort a table when you have blank columns like this. It will cause havoc in trying to do analysis. So you don't want anything like this in your way. You also don't want blank rows. I've seen data sets where they'll like do groupings, like a list of all the states in California, and then there will be a blank row, and then a list of all the states in Nevada, right? And then a blank row. You don't want those blank rows in the middle of your data or blank columns. So this is bad, bad, bad. Well, I'm going to go back to sheet 5. This is also what is known as wide data. So we have we have values, so some sort of numbers, for example, or things that we might want to do analysis on in multiple columns going across. And each column is a different set of values. So that's known as wide data. And we get a lot of data like this from government agencies. Over here in sheet 7, I have this same data in what is known as long format. Now we only have one column with values, the number of deaths, and that year, which previously was the column header, the column headers, I should say, is now its own column and that is a value. So here how many people died of AIDS, HIV in 1990, how many in 91, 92. This format is much more friendly and flexible for something like pivot tables. And there are ways to switch the data from wide to long or vice versa. And sometimes you might need to do that in order to achieve the analysis you want to do. Just remember, like, structure is an important thing, and it might be impeding your analysis at some point down the road. Speaking of structure, here's an example of a real data set I got from the Minneapolis-St. Paul metro area transit police. And they gave me, I'll make this a little smaller so maybe you can see it. They gave me a separate table for each year. So this first table is 2019, each month, and how many crimes there were in each of those months. The crimes that are considered group A, in other words, the most serious, and then the crimes that are group B, these tend to be more not violent generally, although kidnapping, abduction, you would think that would be up there, but they have these two categories, and then they give me a grand total down here. It's very pretty. It looks really nice. There's also what are known as merged cells over here, where it says Group A and Group A, and Part 2, Part 1. These are UCR category, Uniform Crime Report categories. And then they gave me 2020 in another table, and 2021 in another table, and I think I also got 2022 in another table. And what I wanted to do was to see whether crime had returned to pre-pandemic levels, and it's impossible to do that when your data is in 3 separate tables that can't be easily, you can't turn this into a pivot table. Doing percent change calculations is not easy because things are in very weird places. So this is a situation where I turned it into long data and combined all those tables, and I labeled it. These are Group A crimes. Here's the crime. Here's the month, and here's how many, and here's the year. This is much more friendly for a pivot table, and I can very quickly determine which of these crimes may have gone up over time. You can collapse the months in order to get a full year of data very easily using a pivot table. Or you could say, I want to just look at all the January records and see all the crimes in January, all the Group A crimes in January. You can collapse in different ways that you can't do when you get it in these fancy these report formats that a lot of agencies provide. So this took a lot of copying and pasting, but it was worth the extra time to get it there.